data science projects. So I got trained in US in Atlanta on various concepts related to data science, statistics, machine learning, deep learning. After that, I for, formally completed my PG certificate in artificial intelligence and machine learning from Triple IT Hyderabad. I have done multitudes of projects in AI/ML. So basically, we talk about regression classification. So use cases like anomaly detection, credit card fraud risk assessments, equipment failures, survival analysis using statistical methods like uh, gamma distribution forecasting, beta distribution forecasting, uh, classification use cases using Bayesian classifiers, SVMs, decision trees. Also, I have worked on deep learning projects that involve autoencoders, Gaussian mixture models. I have worked on transformer models as well, like creating uh, conversational agents using transformers like BERT, uh, doing work creating application that would perform downstream tasks like sentiment analysis, summarization, Q&A, topic modeling. So initially this was done through Gen AI models like BERT, but once after the release of this modern large language models, I have worked on creating RAG-based architecture for domain-specific conversation with Llama 3, then GPT-3, GPT 3.5. I have worked with open source models like uh, Mistral, and then I have also worked on vector DBs like CommaDB, PGVector, Pinecone. Have also done used extensive prompt engineering techniques like chain of thoughts, few-shot learning, DSP, and fine-tuning LLM models. I have employed
So, let me give you one scenario based question.
Mhm.
For example, your company want to automate the customer support by developing a chatbot that can handle a common query and route complex issue to human agents. And the goal is to improve the response time and the customer satisfaction.
Mhm.
My question here is, explain how would you build a NLP based chatbot for customer support, and tell me the data preparation and model selection and how you would ensure the chatbot provide the accurate and helpful response.
Okay. So basically, the use case here involves creating of a conversational agent, right? So if we decide to use a LLM powered conversational agent, so we have to make decisions on what kind of LLMs we need. If there are various open source LLMs available, there is a bidirectional encoder LLM like BERT available. But eventually, in this case, we would be more interested in exploring conversations related to our domain specific knowledge, right? So there would be some knowledge based KDB articles, there would be SOPs, training materials, and eventually the users of this conversational interface would be some users would be asking questions on top of that, right? So this is domain specific information that they are business specific information that they are interested in, and our basically task is to automate this process so that the live agents or live service desk resources could better employ in solving critical issues. and trivial issues could be handled automatically through this conversational agent. So what I will do here is I'll create a rack-based architecture. In this rack-based architecture, I'll first have to decide on what kind of LLM is required based on budget, security constraints. There are other aspects that we need to discuss with the clients on this. If the client is okay with using models like GPT 3.5 or 4, that is pay as you go models, then we can definitely stage them on a VPC for for secure authentication and authorization, and then use the VPC inference endpoints for create and pass them to our UI UX interface for users to use them. Uh, in this process, once we have the KDB article, once we have the knowledge base SOPs training materials, we can create chunks of uh, passages, and these passages can be tokenized. Once the passage is tokenized, you can use any analytical library uh, to create tokenization. This is tokenized into tokens of fixed length, like 800 to 1000 tokens per corpus. Then we can pass them to embedding model. These embedding models are nothing but trained transformers based on trained on English semantics and syntax. So once our tokens are passed to this embedding model, they will release vectors. Uh, for different LLMs, there is different dimensions vector that is released. For model like GPT, we have 15, 1516 dimension vectors, and these vectors can be staged in a vector DB. Once we save these vectors in a database, vector DB database, then we can, once the user asks the query, we can follow the same process, tokenize them, then create uh, word vectors, and then on the vector database, we'll perform some similarity search algorithms. These similarity search algorithms are like cosine similarity. Then there are distance-based algorithms like Minkowski, Manhattan, then Pearson's. There are other methods as well where we can calculate the distance between query vector and the staged data that is also in the vector form. Once we have done the similarity search, uh, we'll get vectors of similar uh, information, right? This this will be passed to a large language model, and along with some prompt engineering prompts that will be passed to the large language model. Based on whatever the prompt is, the information will be grounded with the large language model, and it will be presented to the user as a response.
Okay.
So this is the whole process of a RAG-based architecture. There are certain hyperparameter fine-tuning that we need to do in this case. For example, setting the temperature, because based on what kind of response we need, if the response needs to be precise, we need to set the temperature towards zero. If the response needs to be more vibrant or elaborate, we need to increase the response close to one, increase the temperature close to one. So that's how it works. Then there are the parameter tuning like token size, context window, that we can also set based on types of conversation, like how long the conversation will run, and what is the context history that we need to pass with each query, along with the prompt engineering prompt. So all these things has to be configured before the conversation begins.
Okay. All right. So, could you please share with me some real-time business problem which you have faced in your existing solution, or maybe you have worked with the previous solution? So, the Prior experience helped me to understand how you analyzed and how this problem is there in this business and how you solved it.
Yeah, that's very important, right? So eventually, when the the working model that we follow in our current organization is we when we get a project, we start a discovery phase. Discovery phase is nothing but engaging with the client and getting as much information as possible related to the use case. uh, so the first steps would be to understanding what is the use case, it is impacting the client. If we provide a solution, what are the guidelines of measuring the accuracy? How does this solution help the client, I mean, the external client? So these things have to be first figured out before we actually start the build process. So we take as much of our project development time to understand the business use case. And once the whole process is actually understood, there are other questions also, like where the data is hosted, what kind of database the client is using, whether the data is partitioned or not. There are other machine learning questions that we need to take into account. So, time questions like whether the data, is there a target variable, whether the so use case is related to unsupervised learning. Everything has to be understood first before the build actually starts. And we have had our issues before. We have had situations where we started with a uh, open source large language model like Mistral, and eventually halfway during the projects we have figured that the accuracy, the response that is Mistral is spitting out is actually not as per expectations. So there are, even after doing permutations and combination with the hyper parameters, we are not getting the kind of accuracy the client actually is interested in. So that is the kind of situations that might arise on regular machine learning tasks. So we start with a model, and eventually there are certain aspects in the model that is not generalizing the data very well. So in that cases, we might have take decision on changing our model or performing certain other statistical calculations before we start feeding the data to model. In the sense, what I mean is creating more features, more related features, features that when the data is not linearly dependent, when there is some other kind of dependency like polynomial dependency, we might need to involve certain uh, basis functions on top of that. So all these kinds of issues are there. So we try to strive for thorough understanding before we start development, and that actually help us in mitigating such kind of issues while in the midst of project development, product application development.
Okay, all right. Let me ask you one about the problem statement or the scenario discussion related to manufacturing or maybe maintenance. The company operates a large manufacturing facility with numerous machines, and then unexpected machine failure lead to costly downtime and repair the expense. Your ask is to developing and predictive the maintenance system to predict when the machine are likely to fail and schedule the maintenance proactively. So, let me know what approach to building a predictive maintenance system include details on data collection, feature engineering, model selection, and how would you handle imbalanced data, and what step would you take to deploy and monitor the system?
Sure. So First example, this example like data collection, like predicting equipment failure. Predicting equipment failure is an industry-based use case. Uh, equipment failure is in statistic we call it survival analysis, right? In survival analysis, what we do is we decide on time to fail. We calculate the time to fail based on factors that is eventually contributing to time to fail. If you have to draw a distribution curve for time to fail uh, output, then you will see that the curve follows a beta distribution. It follows an I mean times to fail, right? It follows the gamma distribution. Two KPIs, key performance indicators. One is alpha and one is beta. The Once we have these two KPIs, we can use them as feature in our like they can be used as a predictor to the data. So in data calculation collection, we'll get the feature that is related to output, right? So there will be aspects like time, then wh- what are what kinds of equipment the machine is running, causation of the feature, whether output is linearly dependent on the feature. So all this type of calculation comes under EDA. Once we have done the EDA, then there is the feature engineering step. In feature engineering step, what we do is it comprises of feature selection, feature creation, and feature selection. In feature creation, what we do is like when I said that we'll do in this time to failure or survival analysis will follow a gamma distribution, right? So there will be some KPIs from gamma that we will create in this feature engineering step. Once we created those, we'll use them in the feature selection step. In the feature selection step, we can either perform some uh, statistical testing methods like doing an ANOVA test uh, with app scores that will give us what are the most important features the model will be needing once we start developing it. So top few features will be marked based on their app score and p values. So in the ANOVA test, we'll get p values. So p values greater than zero point 0, less than 0.05 means that those features are actually very important to the output. And app score, higher app scores would mean that those features are very important. So lower p values and higher app scores will take few of the top most features that are relevant to the output. Once we decide on the features, we can see that what kind of models we need. Like these are usually uh, continuous. These are really continuous feature and target variable. So we'll use regression based approach. We can use regression based trees like uh, decision tree, or random forest, and set the hyperparameters by doing a grid search or Bayesian grid search or random grid search. We'll take the hyperparameters, add it into our random forest model, and run the model and check for the accuracies. The accuracies in the data based on missing values. Then weighted mean square, that is more important because in that case we'll give weightage to some of the rows which have not been uh, imputed. So in that way, we'll follow the entire machine learning life cycle and create model. Once the model is ready, we can save our model, and then we can either serialize the model and host it on AWS, maybe create a containerized image of the model, to create lambda serverless lambda functions to uh, create API endpoints on the model, to access the model and use them, uh, give the endpoints to client or users to test it.
Yeah. Okay. So similarly, for example, the company want to provide the concise summary of new articles to users, and then saving them time while keeping them informed, and the task with developing a text summarization system. So text summarization system explain how you build a text summarization system for the new article or maybe news article, discuss the difference between the extractive and abstractive summarization model selection, how we select that, and then handle and diverse the new topics and ensuring the summarize are coherent and informative for the new article or news article. So in this case, the media industry or some of the industry, they are working on it to train and then summarize the news article, and uh, how effective they are creating a model to deployment to get a productive solution.
Okay. So that's, I mean, the downstream task here is to summarize, right?
Yeah, the main key area is to summarize the.
Okay, got it. So basically, with summarization, we with large language models, the task of summarization is achievable. For example, if we are using any bidirectional encoder model like BERT, the BERT model will eventually take in the corpus text and with some pre-processing like removing stop words and all. And when we can use this pre-processed corpus text to create summary, so we can actually use them like, uh, if we are using BERT, then we can unfreeze the top layer and train the top layer head of the model, BERT model, on tasks that have been already summarized before. We're giving Sieve summarization example. And then once this is trained, we can pass our text to check whether how is the summary coming as a response. Now, what we can do for checking is we can follow statistical method like KL divergence. In KL divergence, what we do is we'll have response from the LLM and we'll have response human curated response. And based on the frequency of words that occur in the summary, we'll do a comparison analysis. It's nothing but we'll create histograms of the summarized passage as well as human curated passage. That is actually nothing but ground truth. And we'll get a score, KL divergence score. And that score we can actually use it to compare different summarization large language model. So BERT is one LLM that does this task. There are other LLMs. Almost all LLMs can do summarization. Like Mistral can also do summarization. GPT, Llama, uh, Cloudy, so Gemini. They will all be able to do the summarization. But how accurate is your summary depends on doing certain tests, and those tests like KL divergence can guarantee give us you a score that can guarantee whether your summary is good or not with the ground truth. And other than that, uh, like I have done a project for transcribing, summarizing the transcribed text from this one Microsoft Teams meetings that your organizations do on daily basis. So based on that, we can create summary of with using an LLM. We can create summary. Uh, Behind the scene, what happens in comparison of these summarized tests is they follow a negative log likelihood accuracy check criteria, and that means that they will create for every distribution they will create histograms of every word that is occurring, and based on what uh, histogram of the actual ground truth they'll make a comparison. And this negative log likelihood or whatever is this algorithm is also used in KL divergence will give it will give you a score, and that score can be used to compare.
Okay, all right. Similarly, for example, the customer churn prediction.
Yeah,
For example, a telecom company want to reduce the customer churn. They have a data set with customer demographic and usage pattern and the historical
yeah,
churn data, right?
yeah.
So, what is your solution approach to handle this?
I always prefer statistical methods first. So first we will create some just we'll do some statistical models like uh, if it is a simple customer churn, creating a gamma uh, gamma feature and then using them on logistic regression. So that would give you the life, survival analysis of this. And if you don't want to get into the slow and process of identifying features or creating new features, then you can use ensemble machine learning techniques like random forest XGBoost, light GBM. All these models are actually quite capable of selecting the best features for you and then only using those features to create to predict for churn. For example, if the there are 5 or 6 features that you have done ANOVA, F-score, p-value test and got the 5 features that would be most impacting the output. Those, if you pass this through random forest, they will eventually come up with the same 5 features. So it will cut the time for development. And then once you have, uh, these random forests are also very uh, optimized to use bootstrapping and algorithms like bagging. So even if the data set is biased, the biasness is taken care of these techniques. These are nothing but resampling techniques. Random forest uses bagging, and then XGBoost uses your boosting algorithms. A light GBM uses boosting. So these are nothing but uh, techniques that help us to actually better generalize the data. There are other techniques also like k-fold validation. So during training process, we split data into train and test, but within train also we'll make split. The algorithms makes a split. Within train also it will create some part of data for training and some part for validation. And with k-fold validation, what happens is the validation set is randomly selected. If we provide 10 as the k of k-fold validation, then there will be 10 sets of data that will be randomly generated within the training data set to do machine learning training. So customer churn is also a great example where we can use either ensemble methods or we can use it classical statistical methods like checking for the gamma distributions, identifying features of the gamma distribution, using those features along with other features in the training process, then doing ANOVA and F-score testing to get the most relevant features, and then writing up an algorithm like logistic regression to predict whether there will be a churn or not, whether the customer will stay or customer is likely to go away.
Okay, all right. So, my last question to you, for example, one of the retail company want to leverage AI to gain the deeper insight into customer behavior and the preference to enhance marketing strategy. The problem is here, how would you approach this project as a solutioning to get the AI, to apply the AI technique. You'd employ such as clustering or classification or natural language processing, but how would you integrate these insight into the company marketing effort?
Sure. Like what you're talking about is called in statistics causal inference, right? Causal inferencing is very important.
Correct.
It's a like study methods to infer causality rather than just correlation. Um, you can give say other examples are like prosperity score matching, instrumental variables and regression discontinuity design. So all these are called causal inference. Uh, so if you are creating a policy and you want to calculate its impact analysis, right? And also if you want to one example, you have other examples like healthcare interventions where you have created a drug and you want to check whether how will it impact the your users of this drug or any marketing effectiveness of the policy that you have brought into picture, right? So all these can be calculated through causal inferences of a branch of statistics. And I'm sorry, what was the second part of your question?
Yeah. Second part of the questions like for example, you'd employ classification or natural language processing or clustering. How you'd integrate these insight into the company's marketing effort?
Yeah, I mean, what I'm talking about is statistical methods, but if you definitely want to go through machine learning methods, then uh, I mean, if you don't have if you don't have the label, right, data is not labeled, you can go for clustering. The clustering would identify, you can employ methods like TSNE. TSNE is a powerful clustering method. K means is there. What they will do is eventually, when based on your data set, they will create clusters of logically similar grouped uh, uh, data. And this logically similar group data would eventually be having certain characteristics that are similar. They are more homogeneous and related to each other. So you can say that uh, like location wise, if there will be segregation based on location, based on purchase parity, purchase power, based on gender, based on other features of the data set. These segregations would be very important. Once you get these segregations, you can easily identify how your data is can be fairly distributed into different groups, and you can make decision on top of that. But what I was talking more was through statistical terms, like the policy impact analysis, difference in difference analysis. So, if I have to give an example, like assessing the impact of a new education policy on students' performance, right? The first step would be to identify treatment and these control groups, like schools affected by the policy versus school not affected by the policy. And then we'll gather data on the student performance before and after the policy implementation. We'll apply the effect by comparing the changes in outcome over period of time between the groups. So this is what I was more talking about.
Okay. All right. So okay, that's good. So let me add on one more question. So for example, the healthcare provider want to build a system to assist doctor in diagnose the disease
Mhm,
based on the patient data, including symptoms and medical history and lab results, and
mhm.
explain your approach to understanding the problem, analyzing the data, and guiding the model deployment. Can you explain how we can deploy the model to assist a doctor to diagnose the disease, or uh, maybe based on the data, patient data or medical
Yeah, sure.
history. Yeah.
So we'll follow the entire machine learning life cycle here.
Hmm.
We'll first get the data.
Hmm.
The get Once we get the data, we'll do some cleaning on the data.
Hmm.
For example, health is healthcare data, right? So it's very important that every part of the data is every cell of the data is very important. So
Correct.
if there are null values, then we'll have to determine whether we need to impute them or remove them completely. So the imputing strategies also have to be determined based on how the feature is distributed. If this is a normal distribution, then we can eventually create new features based on values based on normal distribution. If the distribution is skewed, we'll have to do certain transformation on the distribution. Like if this is a left skewed or right skewed, we can do a box cut transformation, log transformation. Once we do that, uh, we'll do this with all the features. Uh, then we do a EDA, the next step. In the EDA step, what we do is we will follow the univariate analysis, bivariate analysis, correlation matrix. Then we'll check for the dependency, dependency of features with the output. After doing the EDA uh, and the transformation, the next step would be to do feature engineering. So in feature engineering step, we would create new features, whether the if the relationship between feature and the output is not linear, we'll have to identify what kind of relationship that is, whether it is a polynomial relationship or whether it is a log relationship, other kinds of relationships. So this kind of this is actually non-generalized models, right? So non-generalized models will actually do not follow a particular pattern of association. The features would not be particularly associated with the output in a particular manner. There will be randomness in the association. We have to identify what kind of association that is involved, and then we'll have to select the top features that will be impacting the output. We cannot select all the features because there will be more the features that we select, there will be some issues with the model development because there's we call what it because of what we call curse of dimensionality, right? The more the features we have, the better generation model would have on the data. So in that case, identify top few features that is impacting the output. Once we identify the features, we'll decide on what kind of model that we need to use. If it's a regression problem, we'll use a regression based model. Classification problem will use the classification based model like SVMs, KNNs, decision trees, classification decision trees. And then once we create the model, we'll check for the accuracies for regression R2, MSE, RSE, and for classification F1 scores, precision, recall, AUC, ROC curves. These are all important accuracy check metrics. Once we check the accuracies, the next step would be to serialize the model. Once I mean, accuracy is good, the model serialization it will take into effect. Once we have the model serialized, we can use containerize the model and host it on AWS server or any other cloud server. Once we host this on AWS server, we can create endpoints and give the endpoints to the clients to test the model with their unseen data. That is nothing but inferencing. We can create interfaces through Streamlit, UI UX interfaces through Streamlit or Dash or any other JavaScript, HTML web version. We can do that, and then we can that would eventually be mark our project complete. We'll Once the deployment is done, we'll also have to create a automatic pipeline to identify drift in the model over a period of time. If there is a drift in accuracy goes down, then we need to retrain the model based on the data that has been accumulated over a period of time. and then redeploy the model. So this process, whole process needs to be automated.
Have you ever implemented this solution in any cloud?
Yeah, I have used AWS, I have used Azure. Uh, some of my clients are also on Snowflake. So Snowflake is partnered with AWS and Azure and G Cloud. So we can eventually, I have done deployment using
If we
Snowflake.
if we talk about G Cloud, Google Cloud, what are the tool you have to use for the solution?
I mean, G Cloud I have not used extensively. I've used Azure and AWS predominantly. AWS side, I have used SageMaker. SageMaker is nothing but AutoML type of application that would allow us to do end-to-end machine learning operations from doing data cleaning to deployment. So everything can be handled through as AWS SageMaker. Azure side, we have AutoML. That is Azure AutoML that does the same. So any machine learning lifecycle tasks like EDA, feature engineering, feature selection, model development, accuracy checks, model accuracy visualizations, everything can be done through AutoML of Azure.
Okay, all right.
And there are other applications like uh, Airflow is there. Airflow helps us to keep a track of versioning and then also tasks, background tasks that need to be implemented to make sure that our code is up to date and properly versioned.
Okay, okay, all right. So, what is generative AI?
Generative AI is a branch of you can say deep learning that that is actually that is actually probabilistic way of generating new data. So whatever data could be either in the form of uh, pixels in the image or text or voice. So these are human like data that is created, but they are created through machines. That is generative AI.
Okay,
Whatever we had done before in machine learning was kind of deterministic way of doing like classification regression. So we determine the output based on training, but with uh, generative AI, we are actually creating new unseen data that is not that was not there before.
okay, all right. So, what is the advantage of generative AI if most of the industry they are moving towards the generative AI to use for their use case? Could you please tell me or help me out to what is the advantage if we will use generative AI?
So with generative AI, what we are getting is we are getting human-like understanding of data and human-like creation of data. So the main advantage I can think of is I can see the advantage lies in the side of creativity, right?
Okay.
So
How frequently you are writing and involvement of Python coding?
yeah, I have I have had around 8 to 10 years of experience working in Python. So everything that I work on is in Python only. So I have used libraries like machine learning libraries like scikit-learns, NumPy, Pandas, visualization libraries like Seaborn, Matplotlib. I have also used advanced libraries from TensorFlow, PyTorch for doing neural networks.